Santa Clara Valley chapter, and I welcome you to our noontime webinar. This webinar is a little bit different in that you're actually going to be earning 1.5 learning units, and we will be automatically reporting all CEUs for any current AIA members who are signed into this webinar. However, if you are listening by phone or if you are sharing a friend's computer, you'll want to contact me directly to let me know that so that I can account for your attendance as well. Before I introduce you to our presenters, I'd like to test our sound. So as always, if you could please find your question box, and if you could type in your question box that you can hear me. Hello, April. Let's get this show going. There we go. Perfect. I see some folks got good sound. That's also the same box you're going to want to use when you're asking questions of our presenters. And by the way, feel free to type in your questions at any time during the webinar, and we will take them throughout the webinar as appropriate, and we will also do our best to make time to answer all of them toward the conclusion of the webinar. So for now, what I'm going to do is I'm going to turn this over to our first presenter, and he's going to go over the details of how this webinar will be working. We're going to have a presenter, we're going to have some panelists. There's a lot going on in an hour and a half, and I thank you so much for joining us. So for now, let's turn it over to Matthew Rolnick.
Thank you very much, April. Hello, everybody. Glad to have you here. What I wanted to do first is start with just a little bit of housekeeping. So Kevin, who is going to be doing the bulk of our presenting, and I'll introduce him shortly, but Kevin, if you could just bring us to the next slide, please. You'll see that if you want to be able to ask us questions, go ahead and just put them into the question box, and we'll be happy to take care of them for you. You should feel free to ask us questions throughout the program. We will try very hard to answer your questions as soon after they're asked when it makes sense to have a break in the presenters. Next slide, please. A lot of you are wondering, how do I make sense of the 2013 Energy Code? These are the reasons that you signed up for the webinar today. How do I stay ahead of the next round of design codes? How do I begin to integrate zero net energy into my designs? What does zero net energy even mean? And how can I use these changes to help my business rather than being hurt? Next slide, please. We're going to cover all of those today. At the very beginning of our program, I am going to tell you just a little bit about the PG&E programs that are here to help you with exceeding code. PG&E is our sponsor today of the event. Kevin Robison, my colleague, is the first speaker today, and he is going to be telling you, he is the technical lead in our program. So next slide, please. Before we go any further, though, I do want to thank AIA Santa Clara Valley. We've been working with April Becerra, who you heard at the beginning. She has done a great job putting this together, and I know that she's working on an Energy Code Education Day. Details haven't yet been worked out, so just keep your eyes posted for it. If you have more questions or want to learn more about what AIA Santa Clara Valley is doing, here's their contact information. One question that comes in very frequently is, will we get a copy of the slide deck? And the answer is yes. The slide deck will be available, will be sent out to you shortly after, and some additional resources that speakers of ours have provided, speakers and partners of ours have provided as well. Next slide, please. These programs are sponsored by PG&E. Next slide. And as a result of anytime we talk about programs, we just are required to show this disclaimer that funding is limited, and the offering shall at all times be subject to change or termination. Next slide, please. You might be wondering, why is TRC Energy Services on this call? That's the company that I work for. We are hired by PG&E to implement programs. We also help them with doing research on development on codes and standards, emerging technologies, and other energy-related issues. Next slide, please. There are two programs that we're going to be discussing today. The first program is called the Multifamily Upgrade Program, and the second is the New Home Construction Program. Next slide. Both programs have similar eligibility. You must be in a multifamily property. They're open and available to affordable and market rate market rate buildings. They can be high-rise or low-rise. The requirement is that they have to have PG&E gas and or electric service. So there are some areas where you can only get one or the other. You're still eligible. And they have two different definitions. So for the retrofit program, which is for existing buildings, we require that you have 5 or more units. And for the new construction program, it's defined as 3 or more units. Next slide, please. Next slide. The multifamily program is for a retrofit program, and it's designed to be used for whole building savings. So if you are the type of property that only does one apartment at a time, this retrofit program won't work for you. But we have many developers who buy buildings that have seen better days, and they do they reposition the building. This program is a tremendous fit for those. You have to use qualified partners and qualified raters. And you can see more information about this online. Next slide, please. Next slide, please. There we go. So if you have, a lot of times people want to be able to just do like a window upgrade or something like that. This program is not good for that. This program requires that you do upgrades in at least 2 categories and that you gain at least a 10% minimum savings. Next slide. And the incentives on this program run from $600 to $2,250 per unit. Next slide. If you want more information on that, please do reach out to us after the webinar, and we'll be happy to get you more information, and we can talk specifically about your projects. The next program is the California Multifamily New Homes Program. Continue. And it is a public service program. We offer cash incentives. We have energy design assistance and educational opportunities such as this webinar today. Next slide, please. All of these programs are funded by a benefits charge which all consumers pay on their electric bill. The multifamily new home construction program is based on exceeding 2013 code by 15% or more, and by 15% or more, and and the incentives range from $185 per unit. Whoever's typing, if you could just mute your speaker, please. The incentives range from $185 per unit up to around $1,000 per unit. Next slide, please. Here's our contact information if you'd like to get a hold of us. This will also be in the slide deck, and we'll be happy to go over that some more. I'd like to continue on so that we can get on to the meat of our program. Next slide, please. The next part that we're going to be going over is understanding the multifamily energy code. And there's a number of things in the code which are unique to multifamily as opposed to single-family residential or commercial, and Kevin will be talking about some of these as he goes through the code explanations. On the next slide, please. But before I turn you over to Kevin, what I'd like to do is to help you to understand a little bit of the history of the California Residential Energy Code. Most of you probably have a pretty good understanding of it, and many of you have been around since it was first started. So in the late 70s, there was a legislative mandate, click, that sort of birthed Title 24 into existence and had buildings start to look at becoming more energy efficient. In 2008, there was a new mandate which mandated that energy efficiency be looked at not just as a good thing to have, but as a first source of energy. And so we saw a really substantial tightening of the energy code in 2008, and then click. The next, and then in 2013 is the next code cycle, which we're in right now. And 2013 was 20 to 30% more stringent than 2008. The programs that I was telling you about earlier are designed to help you be ready for the next round of code early. The next round of code that's going to be coming out is CLIC 2016, and we are anticipating that this will be in effect for building permits being applied for in 2017, and then the reason we're all here today is to learn about CLIC Zero Net Energy, which is the goal is that by 2020, all buildings designed in California will be zero net energy buildings. And our first speaker, Kevin Robison, is going to talk to you about what that means to be zero net energy and how that affects you as architects and builders to what needs to happen. So with that, I'm going to turn this over to Kevin Robison. And that is it. Thank you very much for your time.
Great. Thanks, Matthew. Hello, everyone. My name is Kevin Robison. I work with Matthew at TRC Energy Services, and I'm one of the technical leads on the multifamily new construction program. So I'm going to talk to you today a little bit about multifamily, but before I do that, I want to first go over some of the goals that the state of California has put in place regarding zero net energy, and as well as those goals, talk about what action we're taking so that we can make sure we reach those goals by 2020 and 2030. After I talk about a little bit about Z&E, we're going to go into the actual building characteristics that we can look at when we're designing buildings to try and meet those Z&E requirements, and then talk about some resources that are available to architects and designers and engineers just to help you along the way. Our goal here in the program world is to help in your design of buildings and make sure the state is able to reach these big, bold energy efficiency strategy goals that they have in place. So with that, I'll just go ahead and start by, just want to go over this slide. These big, bold Z&E goals, residential new construction, the goals that have every new home being built zero net energy by 2020, and every commercial new construction building by 2030. And then likewise, existing building stock, 50% of the residential buildings by 2030, existing buildings, and then 50% of existing commercial buildings by 2040. And then to get all buildings, both new construction and existing, zero net energy by 2050. As Matthew talked about, the increase in efficiency between the 2008 Title 24 and 2013 Title 24 was between 25 and 30%. Look, around 25% for residential and 30% for non-residential. And we're likely going to see a similar jump in the code stringency to the 2016 code, and then again to the 2019 code in preparation for the 2020 Z&E. I just wanted to mention we're almost halfway through the beginning of implementing the 2013 code, and it's only a year and a half that we have until we implement the 2016 code, and we're still seeing buildings originally designed built to the 2008 standards, and we're seeing them now, and they're trying to catch up to the 2013 standards, and we're only a year and a half away from the big next step to the 2016 standards. So I really want to, just reiterate that our team here at TRC and PG&E, the multifamily programs, we're here to help guide you along the way and get you ready for those next steps in code, because they're not easy to reach, and that's why people are still struggling with some of the building designs. And so actually the 2016 code language has already been approved, and what they're stating is that now this is a single family home, not multifamily, but a single family home built to the 2016 standards is about 28%, uses 28% less energy than a home built to the 2013 standard. So we just had a 25% jump, and now we're going to have another 28% jump to the 2016 standards. So they're making big, bold steps to get to Z&E, and that's being shown with the code. So next slide is I just wanted to mention this strategic action plan. It's the Residential Zero Net Energy Action Plan, and it's the plan put in place with many stakeholders, including the California Energy Commission, California Public Utilities Commission, the public utilities, municipalities, builders, designers, architects, and then lots of individuals and corporations that are all working together that have created this action plan. It actually just got published, the final version, in June, and how we're going to reach Z&E by 2020. And this is a living document, and updates are going to be made along the way. So first, I just wanted to show when I think of Z&E, I think this slide is really representative of how. And sorry about that. Looks like it jumped a slide. And how I think about Z&E and the steps we want to take to get there. Now, this is an ideal world, and you don't necessarily have to do all these things to get to a Z&E building. But this is the steps I want to take, and I think there's a timer on here that's pushing me on to the next slide. Sorry, one sec. Let me get this. Okay, I think I have that fixed. So the first step along Z&E is to minimize your building loads, and that's how you place the building on the land if you have that option, which sometimes you don't have that option. And then to maximize your system efficiency, which is your HVAC, your lighting, the hot water, and all the regulated Title 24 loads. And then to go on to your appliance efficiencies, and I'm sorry, this slide will not, I've turned off the timer and it continues to want to jump to the next slide. So to look at the efficiency, appliance efficiencies, the state of California has Title 20, which is in place that regulates the efficiencies of appliances. And the manufacturers must certify appliances efficiencies to the CEC in order to comply with state law. So that's how we're handling that. The last one along that step, and I'm not going to go back to it because it keeps jumping slides, is occupant behavior. Now, it's often said that buildings don't use energy and people do. Well, that's roughly true, but we need to make it easy for people to make smart decisions when they're using their buildings, and that's through good building design. So what I wanted to talk about now is some of the definitions of Z&E that are in place. So there's various definitions of net zero energy being used in the market, and that can make it really difficult to come to a consensus on what definition to use and how we should build buildings to meet which of these definitions. So I'm just going to go through a few of these, the first being net site energy. And so this can be considered one of the more stringent definitions. It treats electricity, natural gas, propane equally, and it's whatever you use on site is you produce on site. So everything being produced is being used on site. The next being net source energy, and this values electricity and fuels based on the primary energy needed to create that energy source. So electricity used at the building was produced by some remote source, likely natural gas. And each of those sources has a multiplier to calculate the total energy embedded in that energy use. One of the difficulties is that these multipliers vary by country and utility because each utility has a different portfolio of their power generation, and so it makes it difficult to kind of true up and equalize and use net source energy as a way to measure Z&E. Then we have net energy emissions, which this is a great one for AB 32, greenhouse gas emissions, and it addresses all fuels equally, but it doesn't necessarily reflect the full costs or impacts of low carbon technologies, and it doesn't address the issues with peak demand that we have on the electric grid. And then we have net energy costs, which I think the average consumer looks at as far as zero net energy, as they see zero net energy means zero energy bill. And that's a lot of people's understanding of zero net energy is no bill. And the last one is net TDV energy. And TDV is time-dependent valuation of energy, which values energy on the time and place that it's used and in what type of building. And the definition is the societal value of energy consumed by a building is less than or equal to the societal value of on-site renewable energy generated. So this is a good metric because it accounts for the value of different energy sources, and it really takes into account peak demand and also incorporates the cost of future carbon emissions. And this is the definition that we're going to use moving forward in the presentation. This is the definition net TDV energy, Z&E, is what the state of California, the Energy Commission, is using to define zero net energy. So this slide is just wants to represent that one side. You'll see the traffic congestion, while the other side is wide open. And the way we build freeways is similar to the way we try and build the electric grid, is that it needs to be able to handle the maximum capacity at the time of use, at the time of day when most people are using it. So we need to have enough availability on the grid so that at the peak demand times that we can still handle all the electricity being used, and we don't have blackouts or brownouts that we've all probably experienced here in California. So a TDV is a good way to, it puts value on that time of use of energy. Just like some toll roads charge you more at peak times of traffic, TDV, it puts a higher value on energy being used at the peak times during the day. And so I just wanted to illustrate that as a kind of a lead into TDV. I'm going to show you a little graph here of time-dependent valuation, which put the societal value on energy by the time of day. And so there's multipliers for every hour of the day throughout the year, and it's based on the energy type, the date and hour that the energy is used, the climate zone which the energy is used, and the building type. Each specific building type has its own time-dependent valuation multiplying factor. So this is what the compliance software uses in the state of California, and this is how energy is spoken about. So now I'm going to get into actually some of the building characteristics, things we can look at as we move towards Z&E. And this first sheet I wanted to show you is a sheet put together by Energy Code ACE, and I wanted to just spend a moment thanking Energy Code ACE for all the work they're doing. And this is also supported by the Energy Commission and the public utilities. This is a fact sheet put together specifically for high-rise and low-rise multifamily buildings, and it talks about the mandatory measures and prescriptive measures in the code, and it's a 2-page document that's just full of good information. So this is just a reference. The website's on here if you want to look at that later. I recommend it. Actually, most of the information I'm going to cover in the remaining slides is either related to or almost directly out of all this bulk of information. So I wanted to talk a little bit about how the code works. And so we have mandatory measures, we have prescriptive measures, and then we have the performance approach, which takes into account both mandatory measures and prescriptive measures. So the mandatory measures in the code are things that we have to do. There's no way around them. There's no trade-offs. If it's mandatory in the code, everyone has to do it. It's just part of the way the code is working. Then there's the prescriptive approach we can take, which looks at each individual system in the building separately, and so you have to meet these prescriptive requirements for each individual component of the building in order to comply with this method. Now that's rarely used. It's really mostly used just in alterations or additions. What almost all new construction is using is the performance approach, which allows you trade-offs between the different building systems. So you can trade off between the envelope, the mechanical system, and the lighting. Mechanical would incorporate both HVAC and domestic hot water. So for a high-rise building, this is true. You can trade off between all three of these. Let's say you have a really good building envelope, you have really good insulation in your walls and ceiling, great windows, and so maybe you don't put in a mechanical system that's quite as good because your envelope's so good that it doesn't require such a high efficient HVAC system. So you can do trade-offs there. As far as low-rise multifamily and single-family, there really are only trade-offs between the envelope and the mechanical systems, and lighting is solely a prescriptive compliance. Lighting has to meet certain requirements, and envelope and mechanical you can trade off. So for example, if you could have a multifamily building, low-rise on the coast, that has a HVAC system that just barely meets the prescriptive efficiencies, and an envelope, say you're still building with 2x4 construction, so the envelope's not meeting the current code requirements. But if you're on the coast, your HVAC energy use is not going to be great to begin with. You're not going to have a huge heating load or a huge cooling load. And so you can offset this mediocre HVAC system and envelope by a really good water heater. And especially on the coast, which I'll talk about a little later, water heating is one of the biggest energy uses you have in your space as far as code compliance is concerned. So I just wanted to, as we're talking about multifamily buildings, there's two distinct routes that we go. It's high-rise residential building, which is 4 or more habitable stories, and low-rise residential, which is 3 or fewer. And so if you have 3 stories multifamily above a garage, that's considered low-rise, but if you have 3 stories of residential above, say, a retail space, that would be considered high-rise because the retail space is considered habitable. And these definitions are specific to the California Energy Code. They may overlap in some areas with other codes. I know specifically Energy Star has a slightly different approach to what they call high-rise and low-rise. So if you're also participating in Energy Star, you may straddle the line between the program and between the 2 programs, one being considered high-rise and the other low-rise, or vice versa. So because we have 2 distinct parts of the code for low-rise and high-rise, I just wanted to show that which building system pertains to which part of the code. So for low-rise, everything in low-rise just pertains to the low-rise code. That's easy enough. And for high-rise buildings, the envelope of the building is under the high-rise code. The HVAC systems are actually part of the non-residential code. Water heating remains part of the low-rise standards, and indoor lights in the actual dwelling units themselves are to the same prescriptive lighting standards in the low-rise code. And outdoor lighting is for non-residential. But this is just a great slide for reference. I work in a lot between the straddle the programs, and I just use this as a reference to remind myself if I'm forgetting. So now I just want to talk a little bit about the actual systems themselves. So this is a slide showing the prescriptive values, and I focused this on prescriptive values only because the prescriptive values are so tough in the 2013 code, and they're going to get even tougher in the 2016 code. And so what we can typically think of is, oh, that's a really good wall, or that's a really good roof insulation. They're not really that great oftentimes when we go and look in the code and look at what they're getting compared against in the prescriptive standards. So on the top here, we have the low-rise roof prescriptive standards. And the top there is the CZ is for climate zone. So we have climate zone 1, and then 11 through 16. The prescriptive standard is R38. And then for climate zones 2 through 10 is R30. And most of you, I'm sure, are familiar with the climate zones, but climate zones 1 through 9 typically are along the coast or close to the coast in California. And then 10 through 16 tend to be more inland and desert areas, and then some of the mountain regions and the Sierras as well. And then the high-rise roofs, they also have some tough prescriptive standards between R24 and R34, depending on the climate zone. So the one detail on the bottom right here is a concrete span deck, and it has a 6-inch polystyrene. So R24 value, and it's just barely, and it's actually a 0.035, so it's meeting 2 of these prescriptive standards. But I mean, 6-inch of poly, I typically see in plan details 4 inches of polystyrene, and so they're going to 6, and they're still barely meeting some of the prescriptive standards. So it's something to definitely think about as you're designing the buildings. Try and maximize the roof insulation as much as possible. Okay, the next one, talk a little bit about walls. And the reason walls are important is just because you have more of them than any other, more surface area in walls than any other component in the building. And the prescriptive standards on walls have gotten really tough as well. So the low-rise walls are at a 0.065 U factor, which is the equivalent of an R13 wall with continuous R5 exterior insulation, which is not all that common. And so if you have a 2x6 framed wall these days with R21, that'll be at a 0.069, the detail here on the bottom left. R21 2x6 wall is at 0.069, so that we normally think of as a great wall, but it's just not even meeting the prescriptive requirement any longer. And then in 2016, this is going to increase again, and I'll talk about that a little later. But the 2016 codes are going to include high-performance walls and high-performance attics as part of the prescriptive standards. And then the high-rise walls, we have the factors here as well. One thing I just wanted to point out, if you're using a metal-framed wall, the only way to actually even meet the mandatory requirement is to use continuous R4 insulation. So if you're going to use a metal wall, you're going to have to install continuous exterior insulation in order to meet the mandatory and prescriptive requirements for a metal framed wall. So here's a similar thing with the prescriptive insulation for floors, and I'm not going to spend much time on this, but just know that those are there as well. And certain climate zones, it's a pretty serious insulation for floors, especially climate zones 1 and 2, R30 in the floors is something to consider. So the next slide is about fenestration, and I'm going to spend some time talking about this. So I think we're all familiar, but I'm just going to go through some of the quick definitions just in case anyone's not.
Hi, Kevin.
Yes?
We have a question
Sure.
relating to the metal studs. And the question is, what about metal studs in low-rise?
In low-rise?
Yeah.
Yeah, so in high-rise, the mandatory, let me get, sorry. Okay, high-rise for metal wall, well, so the mandatory U factor is a 0.105.
Mm-hmm.
And the only way to reach that with metal wall is with the R4 continuous insulation. For low-rise, mandatory U factor is 0.102, which is an R13 2x4 wood wall. So the only way we're going to meet that is actually with at least an R5 exterior insulation.
And so with
the low-rise mandatory U factor is 0.102, and high-rise mandatory U factor is 0.105. So the mandatory wall and low-rise is actually more stringent than the high-rise. So metal and low-rise are going to be the same. It's going to be the same R13 plus, but it's going to be at least plus an R5 exterior insulation.
Okay, thank you.
Mm-hmm. Okay, let's see.
And we have 15 more minutes.
Okay, perfect, thanks. So U factor here, I just want to, I guess I won't go through the definitions. U factor measures the amount of heat loss to space and the SHGC, the solar heat gain coefficient, measures the amount of heat gain from solar passing through the windows. And then CFA is conditioned floor area. And then some of the other terms on this are COG is center of glass, and CMA is a component modeling approach used when calculating the SHGC and U factor values for high-rise fenestrations. So I just wanted to, I guess, focus a little bit on fenestration, because in the projects that I see coming through our program, we see such a large variation in project compliance based on the fenestration. And it's either based on the amount of fenestration, the actual values of the solar heat gain and U factor, or the orientation of the building. I had a building come through the program just recently, only fenestration on two sides of the building. At one orientation, it was compliant with code by 25%. You rotate it 90 degrees, and it only complies by 3%. It had a 22% drop in compliance just because of the orientation of the building. And I understand sometimes you can't do anything about that. This specific project had the same building at various orientations throughout the project, so we had to try and get it up to the program requirements in every orientation. But it's a huge consideration. And one thing we were able to do is install, at least in the design, some overhangs and reduce the solar heat gain coefficient on the building. So even when we spun it in that worst orientation, we were able to get it from 3% compliance to 12%, and they're currently adding some additional features and potentially some HERS measures to get it to the 15% requirement for the program. And window to wall ratio is a huge one for high-rise non-residential spaces. It's the maximum window to wall ratio is 40%. Window to wall, the windows in the building can account for 50% of your heating and cooling loads in the space. So putting quality windows and potentially putting less windows, although you don't want to ruin your design aesthetic, but the less amount of windows you have, the better your energy efficiency will be, at least. And there's also, I wanted to mention, there's requirements now, prescriptive requirements for visible transmittance. So that's here, 0.42 visible transmittance, and that measures the amount of light going through the fenestration. So that didn't used to be in place. So I want to talk a little bit about solar ready requirements on buildings. So this pertains just to single family subdivisions, 10 or more, which we're not really talking about, so I'm not going to go through all the points. But these are mandatory requirements on new developments, and they're mandatory unless you meet the exceptions. So the exceptions are the same on a lot of these, so I'm just going to talk about this second slide, which is high-rise solar ready. So the requirement is that 15% of your roof area has to be available for potential future install of solar. And so that this pertains to hotel, motel, high-rise residential, 10 stories or less, and all non-residential buildings, 3 stories or less. So you have to leave this space available for solar unless you do one of the following. If you already put some solar on there, then you don't need to leave any space. Or if you install a solar hot water system with these solar savings fraction amounts that are listed here, you don't have to leave the space. Or if you provide another area that's a 50% potential solar zone, you don't necessarily have to have the 15% requirement. And then for high-rise buildings only, if you meet all 3 of these conditions listed, then you don't have to leave the 15% solar ready on the building. Just wanted to point that out. And I wanted to focus a little bit of time also on domestic hot water. And the reason is that if you have a multifamily building that's using a central hot water heating system, you get compared against a prescriptive standard that has a solar thermal fraction. So some of your hot water being provided by solar thermal panels. So in climate zones 1 through 9, you're compared against a system that has a 20% solar thermal requirement, And in climate zones 10 through 16, you're compared against a system that has 35% solar thermal as part of the system. So I mentioned earlier, hot water systems are a great way to get compliance in the code and the way that the current code is written. This makes it a little tougher for multifamily buildings because you're getting compared against a system that has a solar thermal fraction. And this picture of the state with the line through it is not exact, but roughly the cutoff between climate zones 1 through 9 and climate zones 10 through 16, with 1 through 9 being along the coast and 10 through 16 being more inland. So I just wanted to show you a few graphs from 2 specific projects we had come through the program, just to illustrate the amount of impact that domestic hot water systems have in multifamily buildings. So the one on the left is climate zone 4, and the graph on the right is from a building in climate zone 5, which are not hugely different climate zones. They vary, but it's not like it's between climate zone 4 and climate zone 12, which are widely different. But the point is here, water heating is a huge chunk of the energy budget, and these 4 energy categories are really just the regulated Title 24 loads. So this doesn't show appliance, plug loads, any processes. These are just the 4 energy components that are being regulated by Title 24.
Evan, we have a question on
Sure.
what we're looking at. The question is cool roof being factored into the example design to reduce the building energy's use load and the capacity of its mechanical systems?
Is a cool roof being included in this design?
That's the way I read the question, yeah. Is cool roof being factored into the example design to reduce the building's energy use load and capacity of its mechanical systems? I guess, yeah. So do these models assume that cool roof is already integrated, or do they get credit for using cool roof?
So these models, as far as I know, they didn't have a cool roof installed in either of these models. And so they likely are just getting compared against the prescriptive standard for the roof emissivity and reflectance values. Yeah, I guess offline I can talk about cool roofs. The slides, the point of these slides is really just to show the impact of water heating and how it compares to the other energy end uses in the building. Climate Zone 4 has a pretty decent heating and cooling load, whereas Climate Zone 5 for this certain building, the budget is almost non-existent, and what they're using is a little bit more, but cooling load is low as well, and that water heating is just trumping all other energy end uses. So here's from those same 2 projects, just showing how the energy budget is being split up. In Climate Zone 4, the water heating was 48% of the regulated loads. Climate Zone 5, it's 70% of the regulated energy load is coming from water heating. So as far as building the building to comply with Title 24, in these climate zones, water heating has to be addressed, and especially when you're getting compared against a system that has a solar thermal fraction. Now, I just wanted to talk about a few resources here that are available, and because I'm not going to go into lighting, but I wanted to show these resources from the California Lighting Technology Center in Davis, UC Davis. And they have a great document here, the Residential Lighting Guide, and you can reference this later. And they also have an outdoor lighting guide, also from the CLTC at UC Davis. And then I probably don't have time to go into it too much. The 2013 code now has some mandatory HERS measures. HERS is a home energy rating system, and these are measures where you have to have what's called a HERS rater come out and do inspections on your project after it's built to verify certain conditions are made in the field. So some of the mandatory measures now are duct leakage, air conditioning system airflow, and then the fan you use in the HVAC AC system, the watts per CFM has to be verified, and then mechanical ventilation has to be verified in the field. So one that's not mandatory is quality insulation installation, QII. But I just wanted to point this out is that it's a great way to get compliance credit, and it's just a great way to ensure that the insulation in your building is being installed correctly, because from what work we've done, this is often not the case, and so it's just something I wanted to point out. So what's coming in the 2016 code? Like I mentioned before, between 2013 and 2016, as far as at least single-family residential, there's a 28% jump in 28% decrease in energy use between 2013 and 2016. And I haven't seen a stat reported for non-residential or for high-rise, but as far as single-family, it's another 28% jump, which is incredible. And some of the things that are going to be included in the 2016 code are high-performance attics and high-performance walls. So the attics, this is extra insulation at the roof deck or at the ceiling that can reduce the attic temperatures by 35 degrees during the summer. And where do many buildings have the HVAC ducts is right in the attic. So that's the reason this one's being highlighted, as we want to do something about all this cool air-conditioned air you have running through the ducts that are in an attic that's 140 degrees. And so this high-performance attic is a way to deal with that issue. And likewise, we have high-performance walls that the builders can choose any method they want, but the prescriptive standards on the walls are going to increase even more than the current values that we showed earlier. And there's going to be some increased standards as far as residential lighting is concerned. And there's going to be a big push for tankless water heaters, which can in some instances use 35% less energy than a standard water heater. And like I said, the 2016 code has already been approved. Language is out there and available if people want to start ramping up. And if you have any questions, you can always contact us at the program because we're heavily involved in that as well. And Matthew, I think that does it for me.
Great. Before we move on, I just wanted to see if there's any. It looks like we have a comment from Sean to clarify. It's a 25% reduction in energy, but TDB, not TDB energy, is not linked to TDB. We'll come back to that probably when we go into the next panel.
Okay, great.
So in our next panel, which we're going to be talking about, is how you can get ahead of code and how this can help you with winning business now. One of the things that people oftentimes feel when new codes come out down the pipe is, oh gosh, something more, it's another hassle. But we have with us today a number of different panelists that have made sustainability a centerpiece of their business process. So I'm going to ask April to please unmute our panelists, and I'm going to ask Kevin to please advance one more slide so we can see who our panelists are. So our first panelist today is going to be Mia Khan, who's president and founder of Domus Development. And I am going to just make sure you see people's names, and I'm going to let them actually introduce themselves because I think that they actually can do a better job than I can. Robert Lindley with YLHA Architects, and Sean Armstrong with Redwood Energy. Let's see. So, Mia, are you there?
Yes, I'm here.
Great.
So Mia, could you tell us just a little bit about yourself and your business and how sustainability really works as a main portion of your as a central portion of your business program and plan?
Great. Yeah, happy to. So I formed my own development company with some partners back in 2003 with a absolute mission and goal to provide new affordable housing options for Californians in infill areas throughout California. And so we looked for opportunities to develop new housing stock within the urbanized areas in California that primarily would link folks to transit, to amenities and services, but at the same time have a very strong sustainability aspect to the dwelling units. Partly that was incentivized through some of the funding programs that are out here in California, namely the California Tax Credit Allocation Committee, which I actually worked on early on in my career. I did assist the state with establishing the first green criteria and what elements we could incentivize, what were sort of common practices and things that we could memorialize as far as practices that should continue to be maintained. And there, we really identified several sustainable types of efforts like recycled products, low VOC, energy efficiency, and over the years evolved the tax credit scoring process to incentivize green projects. And with that, it allows, frankly, the development community to design projects that work within the context of their buildings. Also, what was very important to myself, and I think many others in this field, is making sure that we can have not only assets that are sustainable from an energy consumption standpoint, because we are owners and operators of these buildings. We care very much about making sure that from an operating expense side, we can manage our utility bills. And at the same time, we care very deeply about making sure that our residents are not being overburdened by excessive utility costs. So we're able to deliver incredibly affordable utility costs to our individual tenants because we do many things to assure the fact that the energy efficiency would allow for very affordable energy usage. So yeah, so we're excited to be here, and we'll talk more when time comes. Let others introduce themselves.
Bob, can you give us a quick 1 minute or so, or 2 minutes of how you've kind of come to sustainability? You had some pretty interesting points when we were talking in the pre-conference.
Sure, yes, happy to. So I just very briefly, I'm a California architect and began working in California right about the same time the first Title 24 came into being. And so back in 1978, Jim Vanderin and who was the state architect under Jerry Brown in his first administration, initiated a lot of really great progressive ideas for sustainability in California. So I think when I go back and think about my career, it's really from the very beginning been informed by a commitment to sustainability and also independence in design, actually trying to get off the grid. We were looking at a model way back in those early days in Berkeley called the Integral Urban House, which actually incorporated a lot of energy efficiency features as well as water saving features. It was very forward thinking from that standpoint. And so basically that was a really strong interest of mine as through my studies at University of California, Berkeley. Sim Vanderin's partner is the first architect I worked for in Berkeley, and they had a commitment to sustainable design and affordable housing. And so we tried to incorporate that. And I think this was probably my early training that enabled me to become a better architect to serve a company like Domus that has a really strong commitment to the environment. Since then, I've actually lived in Village Homes, which was an early model of sustainable design in Davis, California. I was the board chairman there for quite a while on the Architectural Review Board, looking at issues like solar access, actually passive solar techniques such as water heat storage, thickened slab floors, shading of windows and doors. So really the kind of the nuts and bolts of sustainable design has been part of my DNA throughout my practice as an architect. And then watching the watching the codes become more and more stringent was actually something I was very happy about, because we were always ahead of that curve in our own practice, and we were kind of heartened to see that become more the standard for development in California.
Fantastic. Thank you very much. There's that's some great information, and I'm glad to hear that. Our next speaker is Sean Armstrong, and Sean is the principal at Redwood Energy. If you could tell us a little bit more about Redwood Energy and yourself and sustainability, Sean.
Sure. Can you hear me?
Yep.
Okay, great. So I started development in 2005, working for Danco Communities and Pacific West Communities, doing affordable housing. And starting a project in 2005 that was 50% zero net energy offset here in Arcata. And then in 2011, started up a consulting business specifically dedicated to 100% solar-powered housing. So 100% solar-powered meaning all loads are electric. All the loads are met with the solar arrays. And so we have like 15 apartment complexes now that we've done that way. And we have a 25-unit housing project and another 48-unit housing project that's 80% complete. So we have a real depth of experience in how to do 100% solar-powered housing. And I guess the value offer I make to my clients is that in low-income housing, as well as market rate housing, because I have one market rate zero net energy apartment complex, you have to raise the rent. In affordable housing, you can raise the rent by lowering utility allowance, and it's a regulated matter of predicting utility allowance and then lowering it down to $5, which is the minimum monthly charge. And then charging all that difference, which might be like $100, is additional rent. It's a regulated process. And I have all these developers who make a profit doing that. Like their net budget at the end is profitable because they went to 100% solar power. So I show people how to do that. And then I also help people with zero net energy ready projects. This is my partner Michael and I. And that's when we do all electric, high efficiency projects that are waiting for the solar array. And in my later comments, I'm definitely going to encourage people to abandon the TDV metric if you're trying to design zero net energy. For any of the other 5 items on that wheel, TDV is counterproductive for utilities, like zeroing out utility bills. It is totally uninformed when it comes to actual energy balance because it does not reflect energy consumption. It reflects peak loads, and so you might get 3 times the budget for air conditioning versus the actual energy consumption, and it's totally wonky. So
yeah, we'll come back to that.
All of the other parts of zero net energy other than TDV.
Okay. And we can come back to that too, actually, because I think it's an interesting, looking at the definition of zero net energy and sort of how it has evolved over time and how it may play into the current markets of how people are trying to plan to stay ahead of code and how they're planning to accommodate it. Would be interesting as well. Mia,
be clear that
oh yeah.
I don't really want to go into too much into TDV, but I do want to encourage people to find the profitable, successful ways to do zero net energy and to focus on profitability. And TDV, like I said, is not profitable, so I'm just going to focus on how it's profitable.
Got it. Great. Mia, when we were talking, you were I think one of the things that's very interesting about you is that you started out as an architect and then went into the development world. And I didn't know if you had, could you talk a little bit about that process and what helped make that decision for you in terms of how you're, in terms of some of the different things we had talked about before?
Sure, yeah. Well, I did graduate with a master's in architecture from Berkeley, also similar to Bob. And I worked in the field for about 2 years and realized that for me and what I really wanted to get out of my career was to essentially build affordable housing. But I realized as a young architect, you only handled one aspect of the design. And then for me, it was more important to understand the problem-solving aspect of what it takes to actually put a development on the ground. So I shifted to affordable housing and cut my teeth in San Francisco. And I worked in some of the most challenging neighborhoods in San Francisco with getting projects approved and all of that fun entitlement work and how fun it is to work in San Francisco. And at the same time, I realized that my strength was more about the visioning of what the buildings needed to be, and I could also set my agenda, whether it be a certain level of sustainability, of going green. Green has always been in my agenda as well. Did a lot of work at Berkeley on sustainability. My thesis was on a sustainable sort of embodied energy type of research project, and we always strive to continue to innovate. And so for me, from the development perspective as an architect, I can let my great architects like Bob do all the hard work of figuring out the components of how the building comes together, but we together work on sort of the vision of sort of what's the goal of this project, what are we trying to accomplish here, and how is this going to fit contextually with the neighborhood. And so all those things are sort of very carefully thought through at the upfront stage of things, but we have sort of goals throughout in terms of what we're trying to hit, whether it's platinum LEED certified, near net zero, you know, achieving higher than Title 24 at either 15 to 20 to 50% of Title 24. So it really, you know, we work together collaboratively in the beginning to define what it is we're trying to do with this project. And I think because of my insight as an architect, you know, I'm able to really work together as a team, but at the same time allow my architect to do what they're really good at, and I go and find money and solve problems.
Great. Thank you. And Bob, one of the things that we had talked about earlier was that not every client is EMEA. Not every client is focused on having sustainability, and you have some in your practice that maybe that's not their main goal. And so this is a question I think for you and also for Sean, which is if you have people who are really looking not necessarily at how they're going to improve the energy performance of their buildings, or not necessarily on the sustainability, or they're like shooting for the very like LEED bronze so that they can just say that they're LEED kind of a thing. How do you work? Can you talk a little bit about how you work with them and how you use your experience to in these and sort of like what the process of working with them is like a little bit differently? And I'd also like to hear from Sean on that as well, because Sean has had some good experience with that too. So let's start with you, Rob. Bob.
Sure. Well, I would maybe piggyback a little bit on what Mia mentioned. That, you know, there are a host of masters that we have to serve when we design a building, and energy efficiency and sustainability is one very important one, but not the only one. We obviously have to look at contextual design, working with neighborhood groups who might have opinions about, you know, scale and you know, height and bulk and aesthetic concerns. And there's funding concerns. So there's, you know, as architects, we're faced with an ever more daunting challenge to create a really successful project. One other one I'll mention is the Americans with Disabilities Act, something that we all get behind, but that does drive a lot of our design direction as a designer. So we're constantly having to try to find the best compromise between all of these sometimes competing agendas. And so from our standpoint as architects, what we really rely on is really good quality energy modeling. That we typically hire a sub-consultant to do that for us because they're up on all the latest codes, and we will present to them a plan. They will come back to us with some cost-benefit analysis of how to meet you know, the computer model, you know, whether it's more insulation, whether it's higher efficiency heating and air conditioning systems, or whether it's generating some photovoltaic energy on site. And so we work very early with them to identify what are the most cost-effective ways we can comply. And this gets back to your question about how do we bring along a client who may not have sustainability as their own personal goal. We can demonstrate through these models that we can save them money over the long term, especially if they're an owner who is paying the utility bill, or they're trying to use it as a marketing advantage, or perhaps selling to the general public a housing product. So it's much more easy now with these computer models to demonstrate up front how savings can occur and accrue back to the owners. The other thing that helps us oftentimes is in the public review process, sustainability has become one of the foremost concerns for planning commissions, city councils. Everybody is very focused, you know, at the policy level. How do we make our world better? How do we, you know, combat global warming, etc. So if you come in with a project that might be controversial in terms of its bulk and height and siting, and you can demonstrate that this is a very green project, that essentially wins you a lot of points in a public setting. People will generally give you the benefit of the doubt when it comes to other parts of the project that may not be ideal. And so that is a direct benefit to getting projects approved and making everybody feel good about them, people who live in the communities, public agencies that approve or disapprove your project. So we find in California, happily, most people are on board with energy savings and water savings, especially now. But there are, very tangible ways we can bring people on board who are not.
Great. Thank you very much. And Sean, do you have something to add to that also?
Yeah. So I think that I'd like to point out sort of how do you make money doing this? Why would you do it? Why would you go beyond code? And an example I'd give is that I have a client locally. He's a born-again Christian millionaire. He owns many, many apartment buildings. I mentioned the fact that he's a born-again Christian and a hardcore conservative because it's a lot of my experience with him in his office is being preached at. But we do have an economic relationship that's totally simpatico. He's interested in profiting on the ownership of his apartment buildings. And so I've helped him design new construction that's all electric, which is helpful for him because he saved construction costs. I just want to be clear, the all-electric design package of using heat pumps for water heaters and heat pumps for space heaters is less expensive to build than adding an additional gas infrastructure to the electric infrastructure you're already putting in. So upsizing your electric infrastructure a little bit is cheaper. Every fixture, for instance, that is gas, you have to put at least a $200 per fixture budget allocation for the plumbing just to deliver gas to a fixture. And on-demand gas hot water heaters are a terrible financial investment because they cost about $3,000 to $4,000 to install. A heat pump water heater, which provides a lower utility bill, has less greenhouse gas emissions, is zero net ready, costs $2,000 to install. Less than half for an all-electric, hyper-efficient heat pump water heater. So my first service to him was to help him abandon his gas strategy, so he saved construction costs. He appreciated that. And then the second thing was to show how much was the value of the PV on average to a tenant, and then he raised his rent by that amount, put a big glossy banner out in front, solar-powered apartments, and raised it if the value was $70, I think he raised it to $80. He has 98% occupancy. People are hugely into it. It's a market rate apartment complex. That's Steve Strombeck, made good money. In 2011, off of a zero net energy building, 100% electric, 100% solar powered, just apartments, just built it.
That's great.
So I have the advantage in affordable housing of having the ability to always model utility allowances and then have the rents automatically raised, because that's not a marketing process, it's a financing process with TCAC. But I have developers all over the state who do not even inquire about the code except when they have to satisfy TCAC. Code is not on the conversational palette. Instead, it's how much is it going to cost to build, how much is it going to use each year in energy, and then how much PV do we have to put on the roof. And my projects that are 100% solar powered in profit, because it's cheaper to build all electric, it's more expensive to add the solar, but it's more profitable to own at the end. In profit, they're like $250,000 to $750,000 for projects that are 40 to 100 units. It's just profitable.
That's great.
This is Mia. I have a question for you. Are those garden-style apartments without elevators and common area lighting, double-loaded corridors, that type of thing? Are you doing this on two-story?
Those are all different projects. So I jumped off a call that was a 3-story apartment complex in Cloverdale, 100% solar-powered, elevators, corridor lights, everything that you'd assume is higher energy consuming. I've done downtown live work underneath, like just storefronts on the bottom floor, apartments up above. It happens on all different housing types, downtown LA, rural Northern California. I mean, the Cloverdale project is an example. For all in, for the 32 farm worker apartments that are 2 and 3 and 4 bedroom apartments, all in, it's going to be about a 250,000 kilowatt hours per year energy budget to produce. And they have enough roof space with the efficiency measures to put 350,000 kilowatt hours of production a year, which is what they're going to do. because solar is so cheap that it's okay. I've got a project in Pasadena. It's a net benefit to them on the construction cost to put in the PV array. They're putting in a 60 kilowatt system that produces about 100,000 kilowatt hours a year, and it's going to be negative $5,000 is their cost after the Pasadena rebates and the state tax credits. Just those two things. So we're going to add more PV because it's a profit. They make profit. Just installing it.
So this sounds really great. I'm a little curious, Mia and Bob, as well as if you have other stories too, about some of the cost differentials that come up when you're trying to look at increasing efficiency and sustainability. In your experience of doing the development, have you been finding also that you have that you can make the trade-offs, or what are you seeing in terms of cost differentials?
It varies in different jurisdictions. One of the challenges is the way that the tax credits view net zero at this point. There isn't a standard, so you have to default to the housing authority utility allowances, which are based on, this is in the weeds conversation. It's usually housing authorities set the base utility allowance, which is in the affordable housing world what you need to net out of rents. And the problem is these are all based on old existing housing stock, many of them incredibly inefficient. And so you end up with big numbers that you have to accommodate. $120 for a one-bedroom apartment in one particular jurisdiction is the utility allowance. And then from an underwriting perspective, you can't actually just say you're only going to pay $5. So you can't use the 120. You have to still underwrite to that 120. Or you do these alternative methods, which are incredibly expensive and very hard to underwrite and very hard to actually implement at the end of the day. So it's all fine and dandy to say you save money, but reality-wise, what we have to go through, it's not that clean and simple.
Well,
and
push back a little bit. My profession is to set utility allowances that are submitted to TCAC and housing financing agencies around the country for pre-funding applications. So the way that I work with my clients is that they give me a piece of raw land with a site plan, usually, really sketch up. And then we'll deliver them back an energy model saying, okay, so you need to put these heat pump water heaters in, this heat pump space heater, this much insulation in the walls, et cetera, things that we think are about cost effective. And this is the amount of solar that will balance that. And here's your utility allowance. So you don't have to use the Public Housing Authority's utility allowance. You use the California utility allowance calculator, which CTAC had invented for this purpose. And so then you have these $5 utility allowances that you finance with from the get-go. And I have 12 clients with 5,000 units now done with that tool, almost 150 projects.
That's good to know. I did that in the beginning, and it failed. Everything about it in the early days was a disaster. So it made us very squeamish going forward.
It's like my bread and butter from 2011 on now. It's just what I do every day, all day long. And as I mentioned,
we can talk offline.
Yeah, I was going to say, let's bring this conversation offline. I have another question, which I was kind of curious a little bit about. I know that there's a lot of code evolution happening, and I wanted to sort of hear what you guys are hearing about when you're talking to your clients and when you're talking to your teams about where you're putting your energy targets now and how you're trying. Are you looking far? Are you trying to strive for zero net energy at these days, or are you still trying to just stay a percentage above current code? And how are you choosing those different targets?
From my perspective, it really relies on incentives that are out there and sort of what programs, what funds we can get to strive for net zero. The one we did was because of a partnership with the local utility agency. We're finding those funds tend to change a lot. The smaller rebates that you guys talked about early on usually don't cut it enough. Right now, it's very challenging to get affordable housing on the ground. It's very competitive, very little funding out there. So people are looking for all different reasons and all different ways to kind of reduce costs. So I think it is a challenge right now for everyone just to assume we're going to go 100%, net zero now, because we're dealing with a lot of costs. And you got to balance all this with everything else: rising material costs, higher labor costs, the fact that everyone's doing different construction projects now. There's a lot of competition for labor and materials. So there's a lot of factors out there. So I think that it is certainly always a goal of folks, but I think sort of whether you go for baseline to, whether you go basic LEED or platinum LEED, really is about cost and where you're going to get those funds to kind of put that together.
Got it. And can you talk a little bit also about, I think one of the things that you just mentioned, and I had during the introductions, this didn't come up, you were the developer, and Bob, you were the architect on a zero net energy project, La Valentina North, which we had done some measurement and verification on. And can you talk a little bit about some of the big findings that you had in that in that experience?
Sure, Bob, maybe I'll let you start.
I'll take a quick stab. So first of all, that project, we actually did that in collaboration with the Sacramento Municipal Utility District, who wanted to have a demonstration project to show that townhouse development could approach zero net energy without any, with basically using existing practices in the development world, so that the similar materials and processes that you would use for a standard development, and try to use that as a demonstration project. So we set that as a target. We ended up getting very close to that. I think they came back after the fact and measured performance, and we were very close to zero net energy. We didn't quite make it. It was basically because we didn't have quite enough rooftop area to support enough solar to balance the loads from the building. But what we found in the process of doing that project is that we focused mainly on the envelope of the building because that's where we felt we could make the most impact, and we developed a wall system that got us to, I believe it was R30 in the wall, with 2 inches of rigid foam outside of a 2x6 wall that also had high efficiency insulation within the wall. So we got about an R30 walls construction, and then we did air barriers and sealing of all the joints in the building to be sure it was a tight building. We used Milgard windows, which is kind of a standard window, but good quality window, and basically our takeaway was if you do a good enough job in the installation of basically materials that are out there and available, you can get a very good envelope. And then we did use some on-demand water heating and high-efficacy lighting and other features in the building that brought us very close to the zero net energy. But it was a bit of a struggle. One anecdote is getting 2 inches of foam to work with a stucco exterior wall finish. We had some pushback from stucco installers who said they didn't have fasteners that could go that deep, and so we ended up developing a system whereby we used steel, sheet metal flashing to get to the 1-inch foam, and then we could attach the lath through only 1 inch instead of 2 inches of foam. That we had to have tested actually for performance to get it approved by SMUD, and in the end we found that the difference in performance was minuscule. So again, that's where the computer modeling helped us a lot in developing that wall section. So there are some growing pains for people who are trying to do zero net energy, that some of the construction techniques and actually warranties for certain systems are not completely up to speed with what we would like to do as designers of the project.
I'm concerned hearing you say that, because I have 1,000 units of zero net energy housing that are built, and only one of them have ever done even an inch of exterior foam insulation on it, only because it was required. 2x6 walls are totally sufficient. Putting a heat pump, an HSPF of a 9.5 with a SEER of 15, that's all you need to do. Putting in a heat pump water heater of a 2.9 energy factor or higher, just blossom on the market for $1,100. That's all you need to do. It doesn't have to be some crazy adventure in wall design. And I appreciate that. But
right.
Yeah,
it
sounds like there's a number of different approaches that can be taken.
Right,
You know,
and I think that's.
I'm really familiar with
my
valve
takeaway.
analysis specifically. I've been a part of presentations on it. So I just want to say that the lessons learned aren't the only lessons. A 2x6 wall is sufficient on every project I've done, just normal insulated R19. That's all you have to do an actual zero net energy project. And the gas water heaters, those are not a zero net energy product because there's no offset for gas. So just putting it out there, that's not really, that doesn't fit 5 of the 6 definitions of zero net energy.
Part of what was happening is that, a lot of this was driven by what SMUD wanted to do with this, and they had some peak energy demands where they wanted us to use gas for for the water heating. They wanted us to use gas for space heating because of the peak energy demands during the midday in a climate like Sacramento. So there's a lot of AC load. So they mandated that we go with a mix energy type of gas and electric on that project. So you may be right with an all electric project that has sufficient roof area to get the solar offset. So I think it's sort of project dependent for us. We kind of take what we're given as architects, usually coming from the developer, and then incentives that the developer has, and then we're working with those. And so in this case, we weren't able to look at just any system that's out there, but rather the system that SMUD wanted us to look at.
Well, I have had
and they actually,
I have had the luxury of getting to choose our own systems and not being, pushed into a particular design box. And so what I want to say, like, this is an experience of many, many, many projects now, is that it costs $5,000 in energy efficiency investment, $3 to $6 grand, but just use 5 as a number. That's what it costs to get a project up to somewhere between 30 and 50% above the 2008 code, and whatever conversion you'd like to do now, it's all different. But nonetheless, that's nice and simple to say. That does get you up there, 30, 50% above code, but that's not very important. The $5,000 is what you need to do to make a project zero net energy ready. And then you'd put somewhere around $5,000 to $20,000 of PV, depending if it's a studio versus a 4-bedroom. Offset.
So I just want to be mindful of the time. We're just winding down, and I really appreciate that both of you have different approaches to how you can get to zero net energy, because I think it's a really important thing, and I think that the definitive answers are still being written, because there are a number of different interests and targets and everything that all developers are sort of trying to strive for. As we're winding down, I had a question for Sean, which was just about the longevity of PV systems and the inverter replacement. But because we're at the very end of our time, I think what I'm going to do is I'm going to put you in touch directly with the asker of that, and then you guys can talk about that.
It's 30 years the panels last, and inverters are 10 years.
Oh,
30
great.
and 10.
Great. And I had sort of one last question, which is for all of you panelists, which is sort of where do you see, when you look at your experiences and your technologies, and where do you see the types of changes that you're looking to create if you were trying to imagine how we're going to get to a zero net energy by 2020 to meet this audacious goal? Sort of where do you think you're going? And I will cut you guys, whoever's talking, I'll cut off at the end of a minute and a half, just because we have a limited amount of time. So what I'll do is I'll start with Sean, and then go Bob, and then Mia, if that's okay.
Sure. Quick innovations, I think, where we're going is that we need to do thermal batteries for thermal energy use, so HVAC and domestic hot water. And so I'm doing projects like that, where we've got tanks of hot water, additional tanks, so we have a battery for the peak loads in the afternoon, and tanks of ice, like Ice Bear over in Japan to manage their much more extreme peak load issues, is do Ice Bear or ice storage. That's one thing of the future, to stop having to use gas, and which totally compromise their goals. Item number 2 is there's a lot of concern around PV, and vertical PV on the walls, and it is being done in projects all over California and New York State right now, with only a small increment more of cost. So running out of roof space is real, but you don't have to settle for that until you get to about a 4-story construction, 3.5 stories really. Everything below 3.5 stories you can do. And so I'm looking at everything above 3.5 stories being off-site PV. But for now, low-rise residential, from 2011 on, is already happened. Zero-net energy apartment complexes and houses that are cost-effective and profitable, it's already happened. So I'm just, I want things to go faster now.
Great, thank you very much. Bob?
Well, I would just say that, as architects, I'll go back to a comment I made before, that we do serve a number of masters. So we don't pretend to be experts in the, the details of energy efficiency when it comes to the cost of utilities or the system, mechanical systems, et cetera. So as architects, the things that we have control over are things like, first of all, which clients we want to work with in the first place, where we want to do our projects, site selection, the overall type of building, whether we're going to go low-rise, mid-rise, or high-rise, orientation of the building on the site, and how to understand the climate and what needs to be done on the envelope of the building to maximize the energy efficiency. And then we turn that over to our mechanical engineers to look at electric versus gas versus on-site generation. So the kinds of things that we want to look at are we want to keep our eye on policy, and we want to try to stay ahead of where policy is headed and try to come up with creative, good solutions for an overall design, and experiment and explore some things. And for us, the best models are ones that have been successful and have worked, that people can look at and say, yes, this is something I could emulate. And in terms of where we're going, I agree. I think we do need to find some way to store energy on site, whether that be with batteries. We're actually working on a project right now in Kauai, and we're putting in a huge solar array on a high school, and we're building a separate building that will be kind of an energy center where we will have battery storage for energy. So we're going to be generating energy. We're going to be storing it so that we can use it in the evenings, or actually on other site areas. So the storage of energy would be a huge thing. If we could do that, we could really get to net zero energy, I think, a lot faster. So that the battery thing, I think the ice bear is something that we've looked at.
I want to move on so that Mia has a chance also. I'm sorry, this was the time thing I was talking about. Mia?
Sure. Well, I agree with everyone. I think we do need to innovate. I think those things are happening. I think we do have a lot of challenges, though, to get this type of housing into the state in all the right places. And that means within the urban context or in an infill context, and it is even more challenging than ever before. It's hard to get projects entitled. It's hard to get projects financed. It's very hard. On one hand, yes, on the consultant side, you have a client. You're going to do that work, but from our side, there's tremendous challenges to overcome to actually get the financing to build these projects and to get the public approvals to get these projects built. In some cases, some jurisdictions, they don't want to see solar panels at all. Their planning commissions, they don't want to see, they would never want to see it on the vertical side of a building, maybe on the roof. Oftentimes, we don't even show it in some cases, in some jurisdictions, until the very end. There's a lot of politics that go into land use, and that's where things need to shift and change, and we need other tools, and I do a lot of policy work as well. Those things need to complement what we're doing here on the ground to make projects more efficient, but until we can kind of clear some of those hurdles, it's going to be hard. It's going to be hard to get all these projects, and I think what's also really challenging is if we have the misnomer that we're going to greenwash everyone because we're going to build 100% net zero projects in the middle of nowhere, 2 hours outside the major metro area, I think that's also a problem. So we need to get the housing in the right places so that we can get people out of their cars, that we can have a much greener type of housing that gets people cleaner air, healthier lifestyles, support our local economies, and reinvest in the cores of many of our cities, and stop sprawling out and building in the edges of town.
Fantastic. And Mia, you actually, this is such a great upnote to end on. I think the building is one part of the energy consumption. How people get to and from the building becomes another very important part. And so urban infill housing, like what Domus Developments does, and a number of other developers who are really focused on rebuilding our urban cores is a tremendous contribution that meets and exceeds sort of some of the zero net energy goals too that we have, because getting to and from places can be very difficult and expensive. I'd like to thank all of our panelists today. It was really great to hear these different perspectives, and I hope that our guests have enjoyed this as much as I have. We will be sending out the slide deck. It's going to be available afterwards, and you will have contact information for all of our panelists and speakers today, as well as the additional resources. So thank you very much for your time. I really appreciate it.
Thank you, Matthew. Hey, just a reminder before we sign off, guys, there will be a survey that goes out to everybody who attended today, and we just want your quick feedback on what you thought of the program, what you thought of the webinar format. And please fill that survey out and send that right back to us. It helps us improve future webinars down the road. So again, team, thank you very much. And now it's time to sign off, and until next month.
Okay, thank you. Take care.
Very good. Thank you. Bye-bye.
Thank you.